all of that said, let's kick off class of how are we feeling in general. This is going into the end of week 1 of SQL. We're going to round out Khan Academy. How are we feeling in general?
I like SQL, and I feel like I'm picking it up. I did have some issues with the homework, but that's okay because I'm sure it was just something small that wasn't quite clicking, so that's okay. But overall, I like it.
Good, good. Nicole, I saw a hand raised.
I was just gonna say, yeah, I think we're in a good pace, but I just kind of wanted to emphasize that it's only a month left, so game time.
Absolutely, yep. A little more than a month left, right? Because early September is graduation, so we still have a little time left, but definitely game time. Just checking in for your capstones. Hopefully at this point you've got some front end pages done. You've got them done in either HTML or React. And at this point you should kind of be finishing out any additional pages, because we're going to be layering in the backend and the database coming up really fast, right? And so this is personally my personal favorite part of the cohort, is rounding out this last part. Because now all of a sudden we get a lot of light bulb moments really fast, right? We get, oh, okay, now we don't only get front end and we get APIs and we get, React, but now we get to use them all together, build out our own APIs, our own backends, our own databases, and start integrating all of that data together. So this is my favorite part of the program, is the last third, where we don't necessarily go faster, but all of these concepts kind of come all together, and that's my favorite part. So all of that said, before we dive into Khan Academy, any questions? Any light bulb moments that we got this week so far, whether it's from Khan Academy, from what we've been learning on SQL, or anything in general on our capstone, or catching up on homeworks, or any light bulb moments we want to share together?
I think even though it's complicated, a few light bulbs went off when you explained the process of getting the data from the parent component into the child components.
Awesome. Yep. Yeah, and the other thing I want to. Oh, good.
The passing of the data down and up through React components.
And I just want to say on that I don't want everyone to think that if you didn't get that, you're not going to get React, because that was the hardest thing of me to get. When I was learning React, I was learning it kind of in a vacuum, right? I didn't know anyone else who learned React, but I knew that it was important to learn that. And I knew that was where the industry was going forward. And I sat there for probably 2 weeks screaming at my computer and going, the data is right here. I know the data is supposed to be up here in the app. I'm getting the data down here. What do you mean I can't update it, right? Like, I've got the array here. I'm changing the array. I'm console logging out the array. It's not changing. And when I figured out you've got to pass that set method all the way down, then use that set method once you pass it all the way down, and that's what makes it trickle back up and update the data. That was my major light bulb moment in React. That was such a light bulb moment for me that I was like, that was when I went from I hate React, I hate React, I hate React to, oh, React is actually pretty cool, right? So if rewatching last night's video, if it takes you 2 hours and you just keep rewatching it and keep rewatching it, I promise you, if you do it slow enough and make sure you understand, what did we leave in Larry's code? 9 comments. Once you understand those 9 comments, I hope that light bulb moment happens in React. And if it doesn't happen, schedule a one-on-one with me, right? Because excuse me, we can try and get you to that light bulb moment with that one-on-one time. And if that isn't working, that's when we can get into, hey, are there some additional resources? Maybe we can point you in that direction and help with that. Larry, you just mentioned he bought a Udemy course. I love Udemy. I love Coursera. The other thing is you can all get Onondaga County Library cards if you don't have one already. And you get through that LinkedIn Learning for free. So I know a lot of corporations pay a lot of money monthly or yearly for LinkedIn Learning. That is a resource that you get for free. And LinkedIn Learning is essentially YouTube for learning resources, right? And they've got a lot of great React courses out there. The one thing I will warn you on in React courses is about a year or two, the industry made a switch from using class-based React components to functional components. If you go through a React-based course, a course that was produced about 3 years ago or later, you're going to get in there and be like, what the hell is this? This is in React. If you're seeing something like this .set state or extends React.component, you're going to be like, boo. They said this is React. They paid for React. Is this really React?
I saw that on a YouTube video and jumped right back out because I said, I know this is a way to do it, but that's not the way we're doing it. That's what I confirmed with you.
Correct.
Matt, how do we activate the LinkedIn Learning? Because I do have a library card and I'm on LinkedIn, but I didn't figure it out.
So LinkedIn actually bought lynda.com 2 or 3 years ago. And about a year ago, they rebranded it all to LinkedIn Learning. With that said, I'm going to send you the link to get into, give me 1 second to pull that link and I'll just send it to you directly because it's kind of hard to find it on your own.
Can I just say something too really quick?
Yeah, go for it.
Use it. So if you go to like our Onondaga, website, like for the downtown, they have like sections for different libraries that we have. And you go to the downtown one, they have it like right on their main website for the downtown library. And then you would click on the LinkedIn Learning, they'll ask for your library card and you put your information and you have access to all the classes.
And I just dropped a link in the CIC Student C3 channel. So you can get to that directly from there. And all you need is your library card, which is going to be like probably 16 digits. I'm guessing off the top of my head, all numbers. And then your PIN that you set up from your online account. And from there, you should be able to get in. And then if you have any questions on that, or if you find a helpful course where you're like, this is my jam, this is helping me learn, please share that in the CIC Student C3 channel. Not only so all your fellow students see it, but also so that I can link to it for future cohorts. I've been going back through and updating our daily outlines to include those kinds of resources. And one of the things that we're going to be spending time on between cohort 3 and cohort 4 is setting up this notion of pre-reading, right? Hey, are there some resources I can read? Is there some homework I can do before the week starts in order to dive in there? Any other questions before we dive into our last part of Intro to SQL? And do not panic, next week we are going into database design. And then from there, we go into actually Node and using the full stack, right? So connecting everything that we've learned this far, connecting our HTML and our CSS into using React and state and props. Then we go into, hey, we've got database design and database SQL down. How can we use that in Node to get our data flowing from our SQL all the way into our React front end? How do we connect that data together? And then how do we build projects using all 3 parts of what we've learned there, the front end, the back end, and the database? Any questions before we dive in? Any other comments? Anyone stuck on any homeworks up until this point? Okie doke. So we are going to dive back into Khan Academy. Okay, so they play a trick on me and start out with a article instead of a video. That's fine. So point of this article. So if you're following along, I'll drop the link into the live stream channel in Slack and also the chat in Zoom. I would encourage everyone to go back through and do these readings after class, but I'm going to do a quick summary here. So so far we've been doing read-only operations, right? Or we've been doing some inserts, which are read and write operation. So important to identify the difference between them. Something like a read-only operation is going to be a select. And depending on how you set up access to your database, it's possible to give users access to read-only only. So we're basically saying, hey, you can only execute select queries if you do an insert or an update query, which we're going to learn in a moment. That will actually lock you out depending on your access to the database. So select query is going to be a read-only query, and then a read and write operation is going to be something like an insert query because we are writing that information into the database. So that is basically the point of this article, is to say, hey, do you have read-only access, at which point you would only be able to execute a select query, or do you have read and write access to the database, at which point you're going to be able to not only execute select queries, but also queries like insert, update, and delete, which we are about to learn in the next video. With that said, let's dive in. I don't know if you can hear that, but I oddly can't. So just give me 1 second to adjust my sound. Okay, let's try that again.
I still don't hear anything, honestly.
You said you didn't hear that? Let's try this one more time. Sorry.
Let's say that we want to create tables to store the data for a diary app. A basic setup would be a users table and a diary logs table. Now, when a user wrote up their diary on the website, we would have some code to execute an insert statement like what I'm pasting in here. So this inserts 2 rows for 2 diary logs, one day after the other. First, where somebody has a horrible fight and buries their woes in 3 pounds of dark chocolate, and the next day, of course, they make up and celebrate with ice cream, as you do. So we can check to see what our diary logs table looks like now, and we can see those 2 posts in there. Now imagine that the user comes back and wants to modify their logs, maybe because they don't want to admit even to themselves that they have eaten that much dark chocolate. Now we've already inserted the data, so at this point we would need to have code that would execute an update statement like this: update diary logs set content equals I had a horrible fight with Ono's guy. Now this is telling it to update that table and set the content, but it's not telling which row to update. We need to tell the database which row to update because we don't want it updating every row with that content, just 1 row. So how do we find the log to update? Well, we can use the ID like that. If we didn't know the ID, we could also filter by columns that we knew were unique to the log, like user ID and the date. It was 2015 0401. But really, if you know the ID, it's safer because you're not relying on having to filter on columns which could actually be the same across multiple rows. If you might have a diary app where users are allowed to write multiple logs per day. It really depends on how the app and the tables are designed. I'll go back to the ID since I know the ID. Now we can do another select to see that our table changed. And it did. No more knowledge of those 3 pounds of chocolate. Okay, so the user made that change, but then the user decides that they actually want to delete the entire log entry. Like maybe because they want to forget that they even had that horrible fight. So in that case, we would need to have code to execute a delete. So we can say delete from diary logs where, and once again, I'm going to use the ID because I know it. And let's select again to see what it looks like. Haha, so we only have 1 row left, which means that our delete worked. Now, you should be very careful whenever you're doing update or delete, because you want to make sure you're updating the actual rows that you intend to update. You don't want to update the wrong rows or delete the wrong rows and lose that data. In fact, some apps never issues deletes. They never really delete rows. Instead, they add a deleted column to their database, and then they'll do something like deleted equals set deleted to true when the user wants to delete, and then they filter based on deleted equals false in the select queries, something like that. So that means that you never actually delete data, which can be a little bit safer, but it's a little more complicated to do that as well. So anyway, that's up to how you design the app. So now with select and insert and update and delete, you have all of the commands you need to handle what a user would want out of your diary app. And now hopefully you can better imagine which commands are happening behind the scenes when you use your favorite apps every day.
Sorry, the scroll is kind of difficult to have all fit on the screen, and unfortunately making the window doesn't expand this area here. Let me see, does dragging it over? No, dragging it over doesn't help much.
You can
either.
get rid of the toolbar or like the bar at the top.
Yeah, I don't think it helps too much, but anyway, general idea here, we're creating 2 tables. Hopefully that is not new news for us. We have our column names and then our data types, as well as something like primary key to give the database heads up an ID is coming. We have inserted data into our tables and we select from them just so we can see the output. That is what is coming out here. Then we use our update query. Our update query is actually not going to return the new updated data, right? We need to run another select query to actually be able to see what that update command actually did. The most important part of an update command before you execute it or put in the semicolon is making sure that you have a where command. This personally, I think, is the biggest downfall in SQL design. If you run an update command and do not include a where filter, it will assume that you want to update every single row in that database, or in that table, I should say. So very important to, when you write your update query, to not forget this where statement, because otherwise you will accidentally update every single row that is in the table that you are trying to update. So that is a big warning of whenever you write your update command, make sure that you include this where. The select is just testing to make sure that our update worked. And then same with this delete, and the delete will do the same thing. If you just say delete from diary logs, it will delete every row in that table. So making sure that you include that where filter to delete that out, very, very important. Zach, go ahead with your question.
I just had a quick question. Last night I was working on the joins, like the section that starts with splitting data into related tables.
Yep.
Were we going to work on that later tonight?
Yeah, did I go out of order in Khan Academy, or are they coming up?
I'm not sure.
Let
Yeah, my
me
question.
double check.
That one was like,
Relational queries modifying. I totally went out of order. The good news is that that won't matter in terms of what we're doing. So we're going to finish the modifying databases with SQL section, and then we will go back to the relational queries in SQL. Thank you for asking about that. Sorry, I just clicked on the wrong link to get started. Danielle, go ahead.
Okay, I had a quick question. I know I had mentioned to you during the time that we had our one-on-one about my capstone that I had to scrap the forum ideal because I didn't have any way to store the information. Could I use SQL to do that? You
most absolutely can, and we will be revisiting that concept when we get into the back end, because it is you can't connect your SQL directly into the front end, right? We need that layer of the back end or the API to be able to interface our SQL directly with the front end, right? So that's going to kind of be the bridge for us. But we will definitely be doing a project where we collect data from the form in the front end, pass it in through a fetch request, kind of the way we did a fetch with New York Times. We're going to do a fetch to our back end. That back end is going to process the data and use SQL to submit that data to the database. And so the first project we're going to be doing is the chat app, where, hey, I send a chat message, that's got to make an API request that goes to my backend. The backend sends it into my SQL database. The database is responding back with all the messages that it has and showing up in the front end. So we will be headed there, not next week, but the following week. And that's where all those light bulb moments kind of fire in sequence, right? Of, okay, now that I've got my SQL and I understand the database design, now we can actually start using that in our full stack projects.
All right, thank you so much.
No problem. Great question. Yes, we can definitely use forms to input the data in our front end so that we can use SQL to store that in our back end, not only to store it, but also to retrieve it back out. Any other questions before we move into the challenge? Okay, so challenge here to get started. There is already a database. It's got a title and a content and an author. Use the update command to update all rows of the author where the author is currently this value, then reselect all the rows to make sure the table changed before we as we expected, right? So the general thing here is that we're doing a select statement here. We are going to do an update command after this. Then we are going to do another select statement to make sure our update command ran as expected. Any questions on this challenge before we take a moment to work on it? Okay. Go ahead.
no, just one more time. Could you repeat what's the challenge again?
Sure. So up here at the top, it's telling you is there's already a database created with these insert statements that have the title, content, and author already inserted, right? So what we're going to do is use the update command to change the author wherever the author name is currently Jackie Paper. We are changing it to be Jackie Draper instead. And then once we use that update command, we are going to run another select command to make sure that our update command ran as expected. So down here at the bottom, after this select, we're going to write two SQL commands, one to do the update and one to select everything again and make sure the update ran as expected. So I'm going to leave the changing rows video up on my screen just so you can reference how we do an update here and another select. And then you guys are going to be working on this challenge dynamic documents to get started. And I'm going to start a poll in Zoom. If you could vote once you get this challenge complete, that will give me a good idea of when to move forward.
Is 47-year-old Charles B.O. McFarland.
Okay.
Was a truck driver for over 20 years. He was getting married in 7 months.
Okay. Changing Jackie Draper. Where's Jackie Draper?
Wayne, can you mute, please? Thank you.
question.
Go ahead.
So because we're using multiple IDs, can we do like number, comma, number, comma, number?
Yep.
Okay.
Now, just be careful because date isn't actually a number. What we're doing in MySQL is I'm sorry, in SQLite, which is what Khan Academy is using under the hood, is we're storing this as a string because there are dashes in it. So you can do number, comma, and then a string for the date.
Wait, for the first,
For the first query you're writing?
wait,
Yeah, I have the same question.
well, because
It's saying it's a syntax error when you do the comment, number, comment in the first. It makes I'm on the same thing as y'all. And I'm kind of stuck on that right now too.
Okay, I'm gonna give everyone 1 more minute and then we'll go through it together and see if that
Okay.
answers your questions. And if it doesn't, you can ask them then.
Okay.
We have 4 votes in on the poll, so I just want to give you guys 1 more minute, but I also don't want you to be stuck for too long.
All right, let me just clarify my question real quick because I want to at least try it.
Yeah, go for it.
For the where ID, you said you could do a string, 1 comma, 2 comma, 3, or no?
So for the where, you want to use your and or syntax. So if you're trying to get your where to be based off of 2 things, you need to say where ID is equal to something and user ID is equal to something else.
Okay.
So when you're trying to do 2 where conditions, you need to use the and command.
Okay. That was a little bit of clarifying.
that actually confused me more. So
Yeah, and I can't put my vote in because I lost the poll.
What was that, Nicole?
Challenge finished.
I was saying that I can't find where the poll went, so.
Oh, okay.
So, okay.
Just give everyone 1 more minute and then we'll go through the challenge together.
I did it. Thank you, Max.
Awesome. Oh, it sounds like we've got 4 votes in on the poll plus 2 unofficial ones. Give everyone just 1 more minute. I did read the feedback form. I do know that you guys have asked for a little bit more time working on the exercises. So give everyone a minute before we dive into trying to do it ourselves.
Yeah, I don't know why I thought like during the update and you do where ID. I don't know why I tried to do author. I'm like, I'm hearing everybody putting in numbers and I'm like, oh, I don't know.
So
All right, let's try and give this a go ourselves. So we've got our document selected, and what, again, important to identify what they're asking us to do. They're asking us to change wherever Jackie Paper is the author to wherever, to the field Jackie Draper. So what we're going to do is we're going to say update. And what are we updating? We are updating our documents table. And what we want to do is we want to set the author to the new value. That is Jackie Draper. And we're putting it in quotes because it's a string. And the update set syntax is using the column name, the equal to say what we're about to set it equal to, and then in quotes, the new value. And then we are saying, hey, we want to update that where the author is currently equal to Jackie Paper. And we're going to spell documents right. And now our SQL should be executing, but we don't really know because this select right here ran and gave us the query before our update command ran. So in what we need to do is another select star from documents, and that is going to show us, hey, Jackie Paper now got updated to Jackie Draper because the first output was this select, then we ran the update, and then we did the select. Zach, go ahead with your question.
If you wanted to update it using something other than the author name, you'd type like where ID equals 3 and ID equals 4.
That should get us to the same point of, hey, we just updated based off of the ID 3, 4, and 5 should all set the author's name to Jackie Draper.
Okay. Yeah, because I solved it. I tried to solve it that way, but I wasn't using and, I was just using commas, so it didn't work. And then I solved it the first way you showed. So thank you.
No problem. So second step of this challenge is now delete a row, being very careful not to delete only the row, only delete the row where the title is things I'm afraid of, which is also the title of me running any delete query in SQL. So we're going to delete from documents where the title is equal to things I am afraid of. And oh, and then we also need to do another select statement from documents to make sure our delete actually worked. So you notice up here, we've got row 5, and now row 5 is missing from our query. Any questions on that before we move forward?
Yeah, can you just give me a second?
Yep.
So, all right. So I see where we did the where that statement. Why is it saying unrecognized token Jackie Paper?
Do you have it in quotes? And do you have your equal sign?
All right, that satisfied that. And then we, I was stuck. So then we go back and we do the select again to show so that it'll update, or so that it'll show us that that's there. I missed.
Yeah, it's not necessarily that. We're checking to make sure the update command ran as we expected. So the update did run, whether or not we did the select. It's kind of like running a PWD in our terminal after we CD, right? We actually did the CD. The CD is done. But when we run the select, that's what our console.log or our PWD is doing. It's confirming that that command ran the way we expected it to.
Okay, and then the next thing we did was delete. Reselect all of those, make sure. Oh, so you know what? I didn't hit next step.
That would do it.
Wait, that's all. Wait, I started typing with that.
All right, we are gonna move forward here just because I think the majority of people are good to go unless anyone has questions. Okey doke.
Wow.
We're back with the database for our diary app. Now, when we first created these tables, like the diary logs table, we decided to store user ID, date, and content. And now I want you to imagine that a few months after we launched this diary app, a user designer suggests adding a "how are you feeling" drop down on each diary entry. And the user would say something like happy or sad or confused. In order to store that, we need to add an emotion column to the table. Now, we could just add it like this, but if this was a database for an app in a real production environment, then we couldn't just edit the create statement because that's something that we actually issued months ago and it's already happened. And if we rerun it, it'll actually remove the current data. And we don't want to lose all the data that we've gotten over these many months. So at this point, after we've done create and after we've got data, we're going to need to use the alter table statement. And to use that, we write alter table and then the name of the table, and then add, then the name of the column name we're adding, and then the data type of that new column. Great. So now the next time that the user makes an entry, we'll need to specify that column, or we can specify that column. So let's say, all right, let's say they went to Disneyland, and to specify that new column, we're going to put comma emotion, and then here we'll just say happy. Most people are happy that go there. Okay, so let's see what it looks like now if we select it all. So we can see the latest row has happy in the emotion column, and the row before it has that big old null in it. And that is what databases usually do. They fill in null for unspecified values. If we want, we can actually get it to fill in some other value for rows where it wasn't set, and that's what we think of as the default value for a column. So to do that, if we had wanted to do that, we would have put default and then the value in that alter table statement when we ran it. So now you can see instead of null, we see unknown. So that's an option for you when you're adding a column, and just something to keep in mind, depends what you're adding to the database. Okay, so now let me show you something that you rarely do, deleting an entire table. Maybe I would do this if I migrated all the data out of this table into some new table, or if I just got mad and decided to be a horrible person and take a rampage all over our database. That's bad. But anyway, we can do this using the drop table statement. And now if I try to select, what happens? I actually get an error because my table no longer exists, so it can't select from it. So that was a bad idea, and I'll just delete it. You should think really carefully about dropping tables. Do not just drop them willy-nilly. You should also be careful with alter table, especially if you're running it on a table with a lot of rows, because you can have performance issues there. Really, I don't want to scare you, but you should be careful whenever you're making any changes to your database. With great power comes great responsibility. And now you have both.
Zach, go ahead with your question.
So is that the way it normally works, where if you modify like previous information, it'll like update it in real time?
For the most
So-
part, yeah. So whenever you run like an alter table command, if you left this default unknown off, every value in that every value in the rows for that column would default to null. And so there are times that if you add a new column, the database, if it's set up a certain way, will say like, you can't add a new column because you didn't specify a value. It can't be null. And so when you run this alter command, it will actually error out. It won't run. It will say, hey, you've got to set a default. Or depending on how the table or the database is set up, it may run and just set everything to default to null if you don't specify this default. But think about this as like, hey, I'm in Excel, right? And I've got 5 columns in Excel and I've got 20 different rows. Well, when I add a new column in Excel and call that notes, what's going to be the value of all of those rows? It's going to be empty or it's going to be null. And that's exactly what the database is doing for you as well.
So in like HTML and other programs we've used, if you have like conflicting information, it gives weight to different functions and like what their positioning is in the coding. What happens if you have like conflicting data in React?
In React or SQL?
SQL.
It will run in the order of your commands, right? And so the one downside to kind of going through Khan Academy is that like this is our entire database, right? In that it's running these commands from top to bottom. But in reality, databases aren't this ephemeral notion of like, once the script is done, our database is gone. The whole point of a database is that it exists after we're done running the commands, right? So if we reboot the computer and come back and run the select statement, all of our insert statements from before the reboot are still going to exist. So it's kind of hard to kind of feel how the database is actually working. But what we're going to find in the upcoming weeks in class is that we're going to create tables and we're going to run our insert statements. And then we're going to be like, oh, crap, we forgot a column, or, oh, we need to change the data type, or, oh, we may need to change the data type from a date that's a text field to a date that the database is recognizing, or we may want to change the name of the column. So that's when we're going to have practice with this alter table, because we're going to be adding columns. And when we add those columns, unless we specify that default, it is going to use the null value. So it really just depends on what commands we're executing. And sometimes we will try to run an alter table command, and it's just going to error out. It's going to be like, you can't do that. And we will have to specify a default or do something from there.
So if you like drop the table, you can't just delete the command saying to drop the table and the table will just reappear. It's
correct.
You type in drop table, it just deletes the table and then there's nothing.
Correct. And there is no command Z on a database either. So when you run drop table, you can't be like undrop table and have it reappear. So what we have going on here is like, as soon as we type that semicolon, the command executes, right? And if we're like, oh, we didn't mean that for that command to execute in Khan Academy, we can just delete the command. And really what Khan Academy is doing is rerunning all of the commands above it. And that's kind of like undoing the command. But when we get into an actual database, we can't just delete the drop table and have everything reappear, because all of these commands for getting the table set up aren't going to be there. So that is why they're kind of stressing the importance of like, make sure before you run an update or a drop or an alter that you actually mean to run that, because there is no, oh, just undo it. The reason why Khan Academy is able to undo it is because it has all of these commands up here. But when we're actually working with the database, we're not going to have the create table sticking around. Once our create table works, we like delete that command and move on to the next one. So that's the only reason why we're able to kind of like undo it in Khan Academy by deleting the command, is because we've got everything that's creating it and inserting the values up here. But once we get into the actual database, we won't be able to use that as a crutch.
So it's not like if you upload like an HTML page to a website where the code is just kind of like auto refreshing. It's like if you're typing stuff into the console log.
Correct.
So it's like you input a command and then that command just executes and then you just have like a blank form again.
That's a very apt analogy. Yes. Any questions on alter table before we go into the challenge?
Just the delete altogether table is just what, drop table again?
So delete is what's going, the delete is the command that allows you to delete specific rows. Drop table is the command that is not only going to remove the table, but it is going to remove all of the data in the table as well. So drop table is like a more powerful version of delete because it's deleting all the rows and the table itself.
Okay, thank you.
Any other questions? Okay, so the challenge coming up is there is a table called close and our insert commands to put 3 rows into it. We need to alter the table to add a price column. So when you're doing that alter table, keep in mind that you need to specify the data type of the price column as well. Then select all the columns in each row to see what your table looks like now. So that's where we're going to get started. I'm going to leave this up on the screen so that you can see the alter table command going on here, and then also the inserts happening after it. But I will leave this up on the screen and I'm going to relaunch the poll just so I know where we're at. We are working on the challenge clothing alterations. And there are 3 steps to that challenge. So once you get done the first step, don't forget to move on to the next one. Zach, don't be afraid to go back to the previous challenges and just fast forward the video all the way to the end. Because if you fast forward it to the end, the commands they ran in the video will show up for you, and it will give you an idea of how to use that update command.
Can you go to that video and go to the end? Like
The update video.
No, the one we just previously watched.
Yep.
Thank you.
4 votes in. We'll give everyone just 2 more minutes and then we'll give it a try ourselves.
Where do you find the poll when you want it?
If you go back into Zoom and kind of like hover over the window that I'm sharing, there the toolbar should pop up with a mute, and then there should be a poll button on the toolbar, and if you click on that, it should pop back up. Like next to chat, there should be a polls button. I could be wrong about that though. I'm not sure how it looks like on your side.
Yeah, I think I just did it anyways. So I'm good. All right, we're all whenever you're ready.
Is there a way to move that little thing off of my price? It's frustrating.
You just click on it and it disappears. Is that what you're talking about?
Yeah, the little, okay, yeah, I wonder. Thank you.
All right, let's try and do this all together. So first things first, they said, hey, we've created a database of clothes. Use the alter command to add a price to the column, then select all the columns to see if it worked. So we're going to say alter table, and we're altering our clothes table. And what do we want to do? We want to add a new column called price with a data type of integer. And we see that our database schema updated, but to see that it worked, we can select star from our clothes table and see, hey, the price got added, but the price for all of them is null. Okay, so now we need to assign each item a price using the update command. And they're saying item 1 should be $10, $20, and $30. Okay, so we need to issue 3 separate commands here. The first one, we need to update our clothes and set price equal to 10. Now, if I accidentally forget to do something here and just put a semicolon there and select star from clothes again, if we look, it has set all 3 of our items to $10. That is the biggest mistake that you can make with an update command, is forgetting to put the where ID is equal to 1. And so if we modify our command, now we see price has come down to 10. And what we're going to do, actually, this should be in lowercase. If we are keeping with our casing, we are able to copy and paste this and just modify the information. So where price is 20 and 30, where ID is 2 and 3. And now we have updated our table, and we can confirm that with our select that all the prices have changed. So finally, insert a new item into the table that has all 3 attributes filled in, including price. Do one final select to show that it all is working. So we're going to do one final insert into our clothes table. We're going to specify our columns, which is our type, our design, and our price. And we are going to say that is going to take the values, and we're going to say jumpsuit, our design is going to be plaid, and our price is going to be $40. So that should, in theory, work, but we don't know that until we select star from our clothes again. And now we are able to see our jumpsuit has been added in plaid for $40. Now, I will say that the order of these commands matters, right? So if we take our insert into clothes and we move that up to here and we run that command, it says, down here at the bottom. Well, that's because we're trying to insert into a column called price when that doesn't exist yet. That price column only got added when we altered the table to add that in. So the order of these commands does matter, right? We can't insert an item with a price until our table is set up to take that column. Any questions there?
Do we have to be careful copy pasting with the semicolon? That'll like cause it to automatically execute, right?
The semicolon does tell Khan Academy, hey, I'm done with this command. However, that is a Khan Academy issue and not a general concern with SQL in general. SQL will not execute commands unless you actually either say run this entire SQL script, or you have a command highlighted and hit the run button on it, depending on how you're executing your commands. But in general, in real SQL databases, commands will not just execute when you add in the semicolon. They'll only run when you either hit the enter key or actually click the run button. But yes, in general, when you're copying and pasting, be careful in Khan Academy, because it is essentially whenever you're modifying this text box in here, it is running every command that has a semicolon at the end of it. All right, any questions on that before we move forward?
Yeah, just give me 30 seconds. I'm
Sure.
just filling
Yep.
some in.
Again, how did you know to do the set the price as an integer?
Integer is just a whole number. So we know we basically
That's how it's going to be inputted on the table.
Exactly. Yep.
All right.
And we'll get into data types a little further on in database design. And we'll also pull up all of the data types that are allowed. It is dependent on your version of SQL that you're using, or the database that you're using version. So popular SQL databases are MySQL, literally MySQL, Postgres, SQLite, which is what Khan Academy is using under the hood, MS SQL, Microsoft SQL, and then Oracle SQL. We'll be using Postgres once we get our database set up early next week. But in general, we can look up the SQL data types, and that's going to give us the options of integer or text or different things there.
I'm all set.
Okay. So last thing that they're going to touch on here in this section of the lesson is making your SQL safer. So it is possible to lock some commands out and basically say, hey, you shouldn't be able to run an update command unless there is a where. And that is just preventing you from accidentally running an update command by accident, right? Same thing for you can run a select query beforehand and make sure that you are only updating the data that you want, making sure by accident that there didn't get two IDs created with the same number. There is also a command that you can use called limit one. And you can use limit not only on update commands, but also on selects and other things as well. If you want to say, hey, I only want this to affect one row, right? So if for whatever reason there is more than one ID, make sure that you're limiting it down. So this update command is only going to affect one thing. Database transactions are something that we're not going to dive too far into, but basically the idea of a transaction is to make sure that all of these commands run successfully. And if for whatever reason this command doesn't run, even though it's the second command, it will actually not make the first update stick in the database because this second one didn't run. So if you're interested in transactions, you can read a little bit more into that. We won't be using transactions in our full stack app, but if you're finding that like, hey, the SQL stuff is kind of interesting and hey, I could like make a whole career out of writing SQL. You want to be looking into database engineers and database architects as job titles. There are companies that are big enough that are maintaining their database where you could literally make an entire career out of writing SQL statements and doing database design, which is, of course, what we're going to be getting into next week. One thing to note on databases is database backups are certainly a thing, right? So we back up our database at work every night at 3 a.m. And our database setup is set up so that the backups actually can't be deleted for 7 days. And so the reason why we have it set up that way is that if a disgruntled developer working at our company, say for whatever reason we decide they're not working out, we give them 2 weeks notice to let them go. And they say, hey, I'm going to screw over the company. I'm going to delete the entire database. Well, our backups are actually set up in a way that even I can't delete our backups if they haven't existed for at least 7 days. So backing up your database, super important. If you accidentally drop a table and say that table has thousands or millions of rows in it, it is possible to go back in and restore that backup. And then the other notion there, similar to backup, is replication of, well, what happens if we host our database somewhere on the cloud and that cloud goes down, right? Let's say AWS or Google Cloud Platform or Heroku or wherever we host our code isn't working. We can actually have 2 copies of our database that are replicating each other. So when you run an insert statement, it's not only going to insert it into your primary database, but there is going to be a replication database or a replication server that is also keeping the server running in the background. So that's the notion of replication. Privileges, we talked about a little bit with read and write already, but you can set up multiple database users so they only have access to read and write to certain tables, or they may only have read-only privileges. So feel free to read through this page. That's all about how we can use these principles in the database to make our SQL a little bit safer so that maybe the user can't execute an insert statement unless they have write privileges, or making sure that we've got replication set up. So if our entire server goes down, we've got a second server that's got all of the data replicated in it. And then also the notion of backup and transactions. Any questions? I know that's kind of a very high level overview of all of this, but any questions on those concepts before we move forward?
No, I have a random question.
No.
In your
I'm sorry, go ahead.
No? Oh, okay. I was gonna say, so in where you work, is there a separate person for SQL or are you the expert?
So it's a good question. So we actually don't use SQL at work, although we have before. We use a database called Mongo. Mongo is the largest primary competitor to SQL or relational databases. Mongo is, because engineers are so clever in their naming, is a non-relational database. So we won't go too far into Mongo in careers and code, but pretty much almost all databases fall into those two categories, whether they are a relational and SQL-based database, or they are a non-relational or no SQL-based database. With that said, we've made the hiring decision that almost all of the developers we hire are full stack developers. So in order to qualify as a full stack developer, you need to know enough about the front end, HTML, CSS, and React. You need to know enough about the back end, Node.js, and how to make an API. And then you also need to be familiar with databases. So we happen to use Mongo, but the principles remain the same. How do you structure data, and how do you do all 4 CRUD operations: create, read, update, and delete? So all of the developers we hire are full stack, meaning they qualify for front end, back end, and database, meaning all of our developers can work in any part of the stack. With that said, all of our engineers do work with the database and are comfortable with those CRUD operations: create, read, update, and delete.
Thank you. That's really cool.
Now, that is not true for all companies, right? Some companies will say, hey, we hire front-end developers. They're focusing in HTML and CSS, and they will work with our back-end developers and work in handling this API documentation and work with integrating that data all the way in. There are some companies that will have back-end developers who are completely separate from their database engineers, right? So if a backend developer wants to store some new data in the database, they'll have to go to the database engineer and say, hey, I want to store this data. Tell me what table it's going to be on. Tell me how to pull that data out. Give me the SQL command, and I will take it from there. And so those database engineers are responsible for actually running the alter table command and making sure that the data type is set up, and making sure that the backend engineers are able to run an insert query and actually have that show up. So it is definitely very company specific. The way our company is structured, because we're a smaller team, we do have a front end designer and developer who focuses on our React code. And then the other 3 members of our team lean to be more full stack and can work directly in the database, in our API, and also integrating that data right into our front end. Okie doke. It is 7 o'clock. We are going to take a break. We will be back at 7:20, and then we are going to dive into the relational queries in SQL. And that is totally not because I did things out of order. So we will be back at 7:20. We are going to go through the rest of this, and that will wrap up our Intro to SQL week, and we'll be able to dive into Intro to Database Design next week. But we will do relational queries coming back at 7:20. And I'll stick around for a minute or two in case anyone has questions. Welcome back, everyone. Hopefully everyone had a good break. Any questions pop into your head during break?
Only where is everybody?
I don't know. Attendance is down tonight. I'm hoping that I get a bunch of screenshot submissions that people are just a couple steps ahead on the lesson and took me up on my offer last night. All right. With that said, let's dive right back in into the relational queries section in Khan Academy. So this article is just talking about, hey, sometimes it makes sense to actually split data into two separate tables, right? So let's say that we've got a table set up for how well students do on the test. And then we also have a table set up for what each student reads. In addition to a students table where we're keeping track of, more information about them, their phone, their birthday. Well, the thing that we run into here is that we're talking about relational data, right? Peter Rabbit here is the same Peter Rabbit as the Peter Rabbit who read The Tale of Miss Tiddlywinkle, and also the same student up here who got a grade on a test, right? And so this is all about relational data. So what we need to do is be able to identify this and break this down and say, maybe we give a student an ID on the students table, and then we can reuse that data to relate all of that information together. So we update student ID both on the reading table and on the test table, and now we can associate that data together. And so the point they're making here is this table doesn't look readable, but what we're going to learn is how to use a join statement in order to get that data together. So sometimes the data that we store in the database may not be the most logical to us, but because it's the most efficient way for the data to be stored in the database, that's what we want to optimize for. So we're not actually optimizing here for readability. We can always modify our select statements to make the data more readable. What we want to optimize for here is making it so the database is storing the information as efficiently as possible. So let's dive into how to use a join statement.
I've set up two tables in this database. A students table with detailed information about each student, like their name and email, and a student grades table, which has their student ID, test name, and grade. Let's see what happens if we just select everything from student grades. Ta-da! Okay, so we see student IDs, test names, and grades. I'd actually rather be able to see student names, emails, that sort of thing. Now, what you might notice is that the student ID in student grades is related to the ID in students. So this 1 here is actually referring to Peter Rabbit, and this 2 here is actually referring to Alice in Wonderland. Now, I want to form a query that will output the student name and email next to each test grade, and that information is in 2 different tables. So that means I need to join the tables. And there are a few ways that we can do that in SQL, and we'll try them all out actually. The simplest is called a cross join. And I can make that happen just by putting both table names after the from. Ta-ta! So as you can see, lots of rows. And basically what this did is that for each row in the first table, it created a row for each of these rows here. That means we end up with 8 rows because it creates 4 rows for each of these 2 rows. This is the simplest join, but it's also the least useful. We don't want every row matched with every other row. We only want them matched if the student ID matches. Now we can do that using an inner join, which isn't actually much more work at all and is way more useful. So there's actually a few ways of doing an inner join. We'll start with just building off the last query, and we can add a where. And the where will check to see that the student ID matches students.id. All right, so now we actually have what we wanted, is test grades next to names, because it's done the cross join and then just limited to the rows where those columns were the same. Great. This syntax here is called an implicit inner join, and it works, but it's not actually the best practice. The better way is if we do something called an explicit inner join. And that is using the join keyword. So to do that, we're going to start with just doing from one table. And actually, I'll do from students, and then join on student grades. And then instead of where, we do on. And that specifies what columns are being matched. So on students.id equals students grade dot student ID. All right, so now we have the same results as before. Switched, but really the same. Now that I have these tables joined, I'm just going to whittle down the columns I'm outputting to the names, the email, the test name, and the grade. Okay, beautiful. Now, the cool thing is, once we've done joins, we can still use where and group by and all those fancy things. Like, let's say that we want to filter down the results to just grades greater than 90. Woohoo! Let's see. Oh, no. Grade. There we go. Haha. Lots of ones above 90. Now I can email all those students with a high five. Okay, but what would happen if my tables both contain columns with the same column name but different meanings? Like right now, our student grades table has a grade column. Well, what if my students table also had a grade column for their overall class grade? That would mean down here, when we selected grade, it wouldn't know which table to pull it from because there'd be a grade column in both of our tables. So actually, to be super safe, we should prefix our columns with the table name that they're from. So we say students.firstname, students.lastname, students.email, studentgrades.test, studentgrades.grade. Okay, now we know that we're going to get the columns from the table we expect them to be in. Great. Now that is our basic explicit inner join, and it is what you'll use for most of your joins across related tables. But if you stay tuned, I'll show you a few other types of joins as well.
How exciting. More join types coming your way. But before we get there, we're going to start off with this challenge. So the challenge is saying we've got a database created, and you notice we are getting to the point where we've got pretty long SQL scripts running here. The good news is we won't be running into that problem once we actually get into our database, because our database isn't just running these scripts, it's actually storing the data. So once we run that insert statement, that data is stored, right? We don't need to pull it back out. But to get practice with our joins, we've got two different tables. We've got our persons table and we've got our hobbies table, right? And we know that this person ID right here in the hobbies table is related to the ID in the persons table. So that's the point of this join, right? Is imagine we've got two separate spreadsheets and we want to pull that data together. We may want to know the person's name who is associated with the name of the hobby, right? So what they want us to do here is say, in the first step, insert one or more row into the persons table, and then insert one or more hobbies that is related to the newly inserted person. So what's going to be super important here is when you get started and you do your insert, you're going to insert into the persons table and make sure that you give that person a unique ID. Then based off of that unique ID that you've given the person, go ahead and create a new hobby for them in the hobbies table that is using the ID in the persons table as the person ID in the hobbies table. I know that's a lot. I'm going to give you guys a couple minutes to give it a try. And if you run into any problems or have questions, let me know. And I'm going to leave this up just so that you can see kind of the insert into and how we use the student ID in this second insert based off of the student ID that is used up here. stuck anywhere, feel free to come off mute, raise your hand, ask a question. Otherwise, give everyone a couple more minutes before we start working on this. Remember, it's this ID that you want to be using in that students table or in the persons table to reference when you do your insert into the second table. In this case, it's the student grades. In the other exercise, it's the hobbies table. Trying to relate that data together so that when we have our insert done, we're able to use our joins in order to get the data out that we want across both table types. All right, let's give this a try together. So first things first, step 1 of 3, we need to insert a new person, right? So in order to insert the person, I need to know what their ID is. So what I can do is I could do a select star from persons and see, hey, we've already got 5 people, right? But instead, what I'm going to do is right before that, because my ID is set up with this integer auto increment, it's going to make the ID for me. So what I'm going to do is I'm going to do my insert into persons, and I'm going to insert a person with a name and an age, and the values are going to be Testy McTesterson, and the age is going to be 99. And so when I put that semicolon in, and don't misspell persons, what is happening? There we go. Now, when I run that select query, because it's after the insert, we can see it's made my ID of 6. Now, I could do that manually, right? I could come in here and just say ID, comma, and make my ID whatever I wanted, and that would also work fine. But if we leave that off and we delete out the ID, comma, we can still reference that ID 6 that got created for us. Excuse me. So it says in the first step, insert one more row in persons and then one more row in the hobbies related to that newly inserted person. So now I can come down here and say insert into hobbies, and the person ID and name is going to be values. And now I want to use my ID of 6, that person that I inserted, and the hobby of coding. Okay, any questions on step 1 there? Now, even though this data is related, we haven't actually tied that data together, right? We actually haven't said, hey, pull in information from persons and pull in information from hobbies, but we have used that same ID so that the database is able to do that, which we're about to do in the next step. So the next step is saying, okay, now select the 2 tables with a join so that you can see each person's name next to their hobby. So what we're going to do is we're going to select, and whenever we select from 2 tables, it's better to name the column that we are looking for from the specific table, because if I just say name here, it's going to be like, what do you mean name? Do you want the hobby's name or do you want the person's name? So we need to be specific in our column and say in our select, hey, we're going to select the person's name and the hobby's name from the person's table, but we're going to join the hobby's table to the person's table on the person's ID, where the person's ID is equal to the hobby's table person ID. Okay, let's take a step back there. We know persons.name, we're saying that the table name and the column name. Then we're saying the table name from hobbies and the column name from there as well. Now every SQL statement needs that from query, right? So we're going to start with the persons table, and then we are going to join in this other table, right? We're merging these 2 tables together, and we're joining in the hobbies table, but we've got to tell the 2 how they're related. So we're going to say, hey, pull the ID from the persons table, and that ID is going to line up with the hobbies table's person ID column. And so now we're getting the person's name and also the name of their activity. Now, okay. So now we move on to the next step. This select up here was confusing it and not letting me move on to the next thing. So I just commented that out, and that's what lets me move forward. Okay, so finally, add an additional query that shows only the names and hobbies of Bobby McBobbyface using the join combined with a where. Okay, so we can copy this whole select statement. This is going to be a good starting point for us. But now we're layering in everything that we already know, right? So we're going to say where the person's name is equal to Bobby McBobby face. And now the only information that we got back is Bobby McBobby face as a hobby of drawing and of coding. And we know that because if we look up here, Bobby McBobby face, drawing, coding, and even if we do a select on our persons and a select on our hobbies, what we're able to see is that in our persons table, Bobby has an ID of 1, and in our hobbies table, person ID 1 and 1, that's Bobby, has hobbies of drawing and coding. So this person ID here is relating the data into the persons table right here. Any questions on that before we move forward?
What was the last part again, please?
So we're just reviewing the data structure. So we're saying, hey, this is the persons table, right? This is the select star from persons. That's what's showing up here. We know that Bobby McBobby face has an ID of 1. So when we look in the hobbies table and we see drawing and coding, because the person ID is 1, these 2 rows in the hobbies table is relating the person ID to the ID in the persons table. So the reason we know that coding and drawing are related to Bobby McBobby face is the ID in the persons table matches the ID of the person's ID in the hobbies table. So this person ID 1 and 1 is referencing this ID 1, which means it's related to Bobby McBobby face. Sanjay, go ahead.
Because I had gotten, oh, I'm sorry.
Oh, no, go ahead, Shantina.
I had gotten an error when I added the where statement at the end, unless I was looking at it incorrectly. But it told me that, oops, you need to fix a previous step.
Oh, make sure I added in 2 select statements here, and I just commented those out. And if you have a select star from persons, go ahead and comment that out as well.
I had, this is what I had worked on it earlier, and I had, this is where I got stuck because this is what I had and it kept giving me that error. So that's why I came to, I was like, okay, I better go to class.
Go ahead and share your screen. Let's take a look.
Thank you.
And then Sanjay, I'll come to you, and then Zach, I'll come to you next.
Is it showing?
Yep, you're good. Okay, so you're doing step 3, but you're missing the work that we did in step 1 and 2.
I had it. That's how I got here. Because then that's why it let me get to step 3. So it deleted somehow?
Yep.
Okay, so for step 1, I actually added, I don't know if it was incorrect, but I added the inserts right onto the bottom of the insert.
That's fine. That shouldn't cause any problems.
And then step 2, it had this. Oh, it wanted me to recop. I just added this line. Okay.
Exactly. Yeah.
Okay.
It wants you to have 2 different select statements at the end after your insert statements.
Okay. So that's why it was saying from. Okay. Thank you.
No problem. Sanjay, go ahead.
I was just asking, and I know Shantina asked this earlier today, or maybe I was yesterday. Where can I get like the terms for, like, you know, where it says into or from, where, join, on, you know, like where can I, is there like a page on the Khan Academy where I can
So there isn't on Khan Academy, but if you just do a search for W3 Schools SQL, the SQL tutorial will come up here. And I know that this looks like a ton of stuff over on the left.
But all
but
around the
thi-
left, that's basically all like the commands that you can do, group by, union, having, exist, like all of those are things that I can do within SQL.
You got it. So like, we're learning about inner joins right now. So if you pull that up, you'll see the on syntax and then the, relating the two tables together. Or if you look at the select is going to give you not only the select and the from, but if you layer in where, it's going to give you the more details on that. So this would be my kind of go-to reference.
Do you mind throwing that in chat real quick, please?
Sure.
Thank you.
It is also in the day 3 outline. Ariel, if you could add that in to make sure that is in the day 2, 3, and 4 outlines, that would be helpful. Zach, did you have a question or did you figure it out with your needing multiple selects? Oh, sorry, Sanjay, I meant to lower your hand and I said unmute by accident.
I have everything typed in the same way you had it, and it's not letting me complete third step.
Go ahead and share your screen.
I don't know if it's just really finicky.
No, I think you are missing the insert of the new person. Unless, is that higher up? Okay, so you inserted Daryl. You did person, name, hobbies. Insert into hobbies. Person's name, hobbies, name, showing hobbies, person. I'm missing something.
I didn't capitalize the F in face.
Good catch. Beat me to it. Any other questions before we move forward? All right, we are going to move on to our left outer joins.
No, sorry.
Go ahead,
Well,
Wayne.
Yeah, I wanted to, I don't know, do the second part over again.
You want me to review it?
Yeah, just real quick.
So the second part being this step here?
Yeah, no, where are you at? Step 2.
Okay. So if we review our data, right? If we look at our persons table and our hobbies table, here are all of our people and here are all of their hobbies. But it's not really helpful for us to know that person ID 3 like skating. What this table is trying to say is person ID 3 is Banana Fofana. And so what we want to do is we want to know, hey, Banana Fofana likes skating and rowing. So what we do is we write a select query that is going to pull data from both of the tables. So we say, hey, from the persons table, we want to pull out their name. We also want to pull out the name from the hobbies table, right? And now we need to tell it, how are we going to relate those two tables together? So the from is going to say, hey, persons is the first table we're pulling from, and we want to join in the hobbies table. Okay, so now we're pulling it from both tables, and now we need to tell it how those two tables are related. So we're saying the join is going to be on where the ID from the persons table lines up with the person ID from the hobbies table.
Okay.
Helpful?
Okay. Yes.
Beautiful. Any other questions?
No.
Okay, moving on.
I'm back with my related tables about students, with the students and the student grades. And I added a new table to keep track of what projects students are working on. And once again, this one has a student ID to relate it to the students table, just like students grade had. And it also has a title for each project. Now what I want is a list of student names and the projects they're working on. So that means I need to join student projects with students. We can do that, as you probably guessed, using an inner join that we just learned. So what do we want? So we want students.first name. We want students.last name. We want the title of the project, so from the students projects table. And then we'll say from students, join student projects, and on students.id equals student projects.student ID. All right, so I see one project, Peter, and his very promising Catapult experiment. But where is my other student, Alice? Well, we're missing Alice because an inner join only creates rows if there are matching records in the two tables. There's no row for Alice because there's no row in student projects that has Alice's student ID in it. And this makes sense, and oftentimes with joins, we do only want rows where the records matched. But in this case, we want a comprehensive list of every student and their project, and we want every student to be on that list, even if they don't have a project yet. And that is where an outer join is super useful. And it's really easy to use. We're just going to go right here and type left outer. Ta-da! Now we see Alice, and there's a big old null for the project title. Okay, so how this works is that the left tells SQL that it should make sure to retain every row from the left table, which is the one after the from, students. And the outer tells it that it should retain the rows even if there's no match in the right table, which is student projects. And that's our outer join. And there's a lot of cases where you might find you want an outer join, and just keep in mind that the behavior of inner versus outer joins. There are also some other sort of outer joins. There's a right outer join, and it basically does the opposite, is make sure that it keeps everything from the right and then joins with the left. We don't actually support right outer joins here, but if you want that, you can just switch the table order and it's the same thing. So you don't actually need to have a right outer join. You can always use left outer join. And there's also something called a full outer join, and that matches rows, if it can, on both the left and the right side, and fills in nulls when it can't on either side. And that's pretty interesting, but also is not supported in our environment here. And that is one of the interesting things about learning SQL. I'm showing you lots of things that work here and work in other SQL environments, but every environment is a little different. So you'll constantly be tweaking the tools in your SQL toolbox for each new environment. And that's true about a lot of things with computers, honestly. You'll learn the general techniques and then learn how to adapt it for a specific language or app or environment. And you basically just get really good at learning. So yay!
Okay, so just one thing to note here is that we don't tend to use a ton of left outer joins in actual practice, this is kind of where you cross that threshold of if you are going hard in SQL, right? If you're like, I want to be a database engineer, you are going to use all kinds of joins, and you're going to end up writing SQL scripts that are hundreds or sometimes even thousands of lines long. However, as full stack developers, this is kind of where we start teetering over that threshold of having more SQL knowledge than we actually need to create our applications. So in our applications, we use joins all the time. However, the vast majority of the time, we are going to just use an inner join. It is very infrequent that we will need to use a left outer join. In other words, we want all of the data from table A, and we want that to overlap with all of the data from table B. But if that data doesn't exist in table B, still make all of the data from table A show up. And that's exactly what that inner join is meant to be doing here, right? Our left table is our students. And so what we're saying is we want the student to show up no matter whether or not they have a project in the student's project table. And that's what the left outer join is doing, is it's saying, hey, always show all of the data in the left table, the students table, but on the right table, which happens to be the students project, line them up if you can, show the catapult is the project in the right table. But if there is no project in the right table that matches this student in the left, just show that data as null. So all of the concepts moving on from here are a little bit over what we need to cover from a full stack perspective. So what I'm going to do is I'm actually going to skip these challenges. They are going to be optional if you want to do them. There's no homework assignment. But I want to touch on two things before we finish off the evening with the final two videos and call it a week on Intro to SQL. One thing, office hours, I sent out that link yesterday. I sent it out again in the chat tonight and in Slack. If you could all take a moment to vote for what office hours time works best for you. That way we can pick that before we sign off tonight and we have that set. The other thing I wanted to touch on, the homework for this week is going to be a website called SQL Bolt. There are 18 different lessons. Hopefully everything that you are seeing in the SQL lessons here are lining up with everything that we did in Khan Academy. This is kind of, okay, let's introduce you to all the concepts in Khan Academy. Now, layer 2 of our SQL approaches, now go get practice with them, right? Go through these lessons, make sure you're understanding them. And each one of these lessons is going to give you a little breakdown of everything that we're covering. Shanjay, I'm guessing office hours are going to be Sunday at 5, but there was a little pushback and people said that they wanted a poll just to make sure that Sunday at 5 worked best for everyone. So I did send out that Calendly link. And I'm guessing there are going to be a couple more people voted in. Yeah, we got 4 votes in. So I just posted that link. That link just to confirm that that time works best for everyone. Any questions on SQL Bolt or office hours before we move on? Doug, I see you've got your hand up. Doug, did you have a question?
Yes, I'm sorry. I thought you were waiting for questions on SQL Bolt before.
Nope, go for yours.
Yeah, so on this exercise, you're doing left outer join, which is saying include the rows from students, even if they don't coincide with the rows from student projects.
Correct.
So then what is the students .id equals student projects.student ID? Is that still doing anything?
That is what's pulling catapult together.
Okay.
Right. So it's saying include all of the students, whether or not they do have data in students' projects. But if they do have data in students' projects, still line that up together in the same row.
Okay, thank you. Yeah, I think that makes sense.
Yeah, if we take, I think this will actually, yeah, so it does some weird things. Now it's saying Alice is trying to get catapult in because it doesn't have the detail of where the tables are supposed to overlap. So that's what the on is doing, is it's saying, hey, try and line up the two tables together, but if you can't, still make the data from the left table show up.
Got it. Thank you.
Any other questions on this or in general before we kind of sprint over the finish line and go over these last two videos just to make sure that we've covered everything?
I might actually go back 1 second. The last part of the Bobby Hobby Challenge.
Yep.
Where oh, there we go. Where person's name equals, okay. I was putting where person's ID equals and it wasn't going through, but yeah. Thanks.
Any other questions? You guys can definitely practice with inner joins. The only reason I'm not going to spend class time here is because we are down a day because of the 4th of July holiday. So I just want to make sure that we get over the finish line with these concepts. And the only reason why I'm okay kind of accelerating the way through it is because in the 10 years that I have used SQL, I spent hours and hours in class learning about left outer joins and making sure I fully comprehended them. I've never in my 10 years of professional software development ever used a left outer join in my code. Or done a self join. I have done multiple joins, but I've never done a self join or a left outer join. It's an important concept to know. And if you guys are going into data engineering or database engineering, two separate titles but related fields, definitely important to spend more time learning SQL. But just because we aren't going to use these concepts in a full stack app, I'm just going to make sure that we get over to that finish line. Okay, moving on to the last two videos.
I'm back with just the table about students this time. I've added one more column to the table, buddy ID. See, I decided that every student should have a buddy, somebody that they can pair up with, do assignments with, study with, all of that. Now, the buddy ID is what it sounds like. It's an ID that relates to the ID of the student that they're buddied up with. So, for example, here, Peter is buddied up with 2, and 2 is Alice. Let me just do a select that should make that more clear. So select the ID, first name, last name, buddy ID from students. Okay. The interesting thing here is that this buddy ID is a column in a table that's related to another column in the same table. That's a bit different from before, where we'd have columns related across different tables. So, what if we wanted to show the names of each student next to the email of the buddy? Not just the ID, the email. To do that, we need to actually join the students table with itself, because the two bits of related data that we need both happen to be in the same table. We can do that by, let's see, so we want the first name, last name, email. So to join students with itself, we're going to write from students and then join students. Okay. All right. Okay, so we get an error. First name is an ambiguous column. And that's true. We're telling to select first name, but it's joining across two tables, and both of these tables have the same column names. And before we would just prefix these with the table names, but we can't do that here because actually they're both named students. So we need to give it a way to distinguish between this one and this one, even if they're kind of the same thing. And we can do that by giving one of them an alias. So we're going to write the alias right after here. The alias is like a nickname. So here's the alias, buddies. And then we just have to specify that the email is coming from buddies.email. Haha. There we go. Now we're seeing too many rows, way too many rows, and that's because we don't have an on clause yet. So it's just joining every possible row with every other one. Now our on should check that the buddy ID from the students table, that first one, matches the ID from the second table, buddies, or what we called buddies. Haha! Now we can see Peter with Alice's email address, Alice with Peter's, etc., etc. To make this results table even a little more clear, I'm going to rename Buddy's email as Buddy email. Okay, so now it's a lot more clear that we're looking at Peter Rabbit and his buddy's email. Cool. Now this type of join is called a self-join, and that's because it's a table being joined to itself. You can try this out in the next challenge, and I'll show you one more way to use self-joins in the talk through after. I hope you'll join me. If not, just join yourself.
All right, bad join puns aside. Again, I've never actually done a self-table join here, but the general thinking is if you want your one query to return out information based off of information in the same table. In this example, what they were trying to get at here is that, hey, because buddy ID is referencing another buddy in this same table, right? In the same students table, what we are trying to get at here is that, hey, Peter Rabbit, their buddy is buddy ID number 2. Okay, buddy ID 2 is Alice Wonderland, and Alice has an email of alice@wonderland.com. So if we wanted to pool all of this data together and reference buddy ID in this same table, we would be able to say, hey, Peter Rabbit's buddy email is alice@wonderland.com. Right. So the idea here, the whole point of a self join is that the ID is referencing something in its own table. So this is one of those things that if you don't understand what kind of data you're trying to get at, you're never going to understand why you would ever use a self join. The whole point of the self join is that if the ID is referencing an ID in its own table, that's when we want to join the two tables together. But if we join the two tables together, we just need to name the table in the join command so that when we reference the column, we're able to reference the table that we're joining it together with. Again, if this is something where you're like, why would we join two of the same table together? The answer is that, like I said, well, the concept is good, and while this would be tested if we had a big SQL test at the end, this would be a concept that you would have to test on and be able to pass for a SQL certification. But in terms of full stack application development, I've never actually had to do a self join to the same table. With that said, do we have any questions on that before we get to the finish line and get to our last video? Okay. Multiple joins and we're done.
Now I want to show you a combination of joins and self-joins. So this time I'm back with multiple tables, tracking the students and their projects. Now, since I have students working on great projects, I want them to review each other's work in pairs. For example, hyena habitats should review carpet physics. That's why I've created this new table, project pairs, and all it stores is 2 project IDs that are paired with each other. Now let's see. What do I see if I select star from project pairs? Ugh, okay, it's just a bunch of numbers, a bunch of IDs, all the IDs that are mapped with each other. It is not the most human readable output at all. What I'd like instead is rows of project titles paired with each other. The project titles are in the student projects table. So that gives me a clue that I need to somehow join project pairs with student projects. Let's see what happens if I do that. Aha! So now we see project IDs and project titles in each row. What I eventually want in the results table is to see 2 project titles in each row, not just 1. So that's another clue that we need to do another join, a self-join of student projects with itself, so that we can get those same column values twice. Now, it may not be obvious how to add a self-join at this point, because we already have a join. If we want to add another one, we can actually use the join keyword again. So join student projects, and we need to make sure we give them different aliases so that they're not ambiguous. So A and B. All right, so now we've got a lot of stuff in this results table, but if you'll scroll, you'll see that the project titles show up twice in each row. So maybe let's make it easier to see. A.title, B.title, great. But we still have way too many rows because we're matching every row with every other row, and we haven't added the on clause, the very important on clause. So we're actually going to add 2 on clauses, 1 for each of the joins. So on project pairs, that's project 1 ID equals A.ID. And then on project pairs dot project 2 ID equals B.ID. Aha, there we go. So thanks to this combination of joins and self-joins, we can see a nice list of project titles paired with their project title. Now you can use as many joins in your query as you need to get the data that you want, but generally more joins mean slower queries. If you're interested in how to figure out if your queries are slow and making them more efficient, we'll talk about that soon. So stay tuned, keep at it.
Okay. Made it to the end. I know we rushed a little bit at the there. I have used multiple joins before, right? What this notion of the project pairs is this is called a bridge table. This bridge table is what is setting us up to link data from the student projects to other projects also related to the student projects table. We're going to get into why that's important in our database design starting next week, of how we're able to design our tables and know when we need multiple ones. But this general idea is super important, right? Of, hey, project pairs is not helpful for us, right? We don't really care what the IDs are. What we want to know is, hey, what project title is paired with the other project title? So we've already practiced that join before, right? Of, hey, we can use student projects to get the title out of the database using the project ID stored in project pairs. What we're doing here is just joining another query onto that. And we're saying, hey, we're referencing student projects again. We're going to call that B. And then we're going to link the B ID to the project ID in the project pairs, table. No, that's a lot. I know you guys didn't get a chance to practice with that. I would encourage you guys to do these challenges that we skipped over. However, they are not required. They are not due as homework. The homework for this weekend will be practicing with SQL Bolt. And then as you complete those challenges, go ahead and just screenshot this side over here, and submit those as your Canvas assignment. With all that said, Ariel just posted the feedback form. Super
Is the
helpful for you
homework-
guys to fill that out, just so we've got an idea of how this week went, how you like Khan Academy. If you want to hold off on filling that out until after the weekend, so you can include some of the feedback on SQL Boat, that would also be completely fine with me. Office hours, we do have 6 votes in, and Sunday at 5 seems to be the best time for everyone. So I am going to go ahead and book that. I will see you guys then. And I just booked that. So if you filled out the Calendly, you should get a link to that as well. Same Zoom classroom link as always.
Is the homework in Canvas?
Homework is in Canvas, although you're making me doubt myself. So I'm going to double check and make sure that it is. Yes, homework is in Canvas. Assignment 50. Made it to 5-0, everyone.
All right. Have a good night, guys.
Have a good
Stick
night.
around in case anyone has any questions. Otherwise, awesome week, everyone. Thanks.
Night.